Hello everyone. Now I am showing you another reactions which is very simple reaction that is called siloxycarbonyl compound trimethyl siloxy group. Uh, if you have trimethyl siloxy group in your compound and you want to kick out the trimethyl silyl group from there to make the hydroxyl group, so you can easily do it by using TBAF solution. So in alpha position of the carbonyl group, if you want to make the hydroxyl group, you can use TBAF, that is called tetrabutyl ammonium fluoride. So normally fluoride source is effective to kick out the silyl group. So here I am showing how tetrabutyl ammonium fluoride looks like. So there will be 4 butyl group in nitrogen, and it is a positive ion, so that's why ammonium, and fluoride ion, so tetrabutyl ammonium fluoride, that is in short called TBAF. So normally TBAF in THF, tetrahydrofuran, the solvent, just for 2 minutes this silyl group will be kicked out from the from your siloxy compound. So this is very simple method, but it is effective. So now here I am showing how to do that. So take your crude, like here I am dissolved my compound in DCM, and I am transferring to a small flask which is flame dried small flask, and after that I will remove my solvent DCM from this flask. Now I'm transferring here in a small flask. So once it is done, I'll rinse the big flask 1 or 2 times, and to make sure all of my compound is transferred in this small flask. So you can see that what I'm doing, I'm just rinsing the big flask by DCM, so that all of the compound is coming in the solvent, like DCM solvent, and then I'll transfer it to the small flask. Here now I'm transferring, and once it is done, then I'll start doing rotobab to remove the solvent, because this is DCM. I dissolve my compound to transfer in a small flask, so I dissolved with the DCM, so I need to remove all the DCM from the compound. So here I am going to use the rotobab. So first I am turning on the vacuum to attach the flask, and also I am going to use a cake clamp to attach the flask so that it cannot fall down in the water bath. So here is the cake clamp, and now vacuum is on, and I start rotation first before touching the water, because water may be a little bit hot. So if you touch water immediately, then it can bump inside the anti-splashing flask. So here, once the bubbling is little bit decreased, then I touch the water, and I will close the vacuum knob from the rotobab from the top side. So now solvent is going to be dried, and now you see that the compound become solid in the flask, and I will turn off the vacuum now and release the vacuum from the rotobab, and now I'm detaching the flask from here. Once it is done, then I will attach a rubber septa on top of this flask with a needle. Then I will go to the vacuum high back pressure or high vacuum low pressure vacuum pump to remove all the trace amount of the solvent from the flask. So now I'm attaching a needle in through the rubber septa, and let's connect the flask in the vacuum pump. So turning on the vacuum pump here and connecting the needle with this tubing, um, now keep it there and turn on the vacuum line perpendicular. Here I turned on the vacuum already, so yeah, this is on, vacuum on. So it need to be dry at least 20 to 30 minutes. Depends on how effective your vacuum pump is. So our vacuum pump is very effective, so with 20 minutes it's enough to dry this sample to go for the reactions. So I keep this flask for 20 to 25 minutes. Once it is done, then I'll start reaction. So after 20 minutes this drying process is done, so I'm gonna stop the vacuum and I will turn on the vacuum pump. Then I will detach the needle. I will not keep the needle with the rubber septa, because if I open from the needle then it can suck the air inside, so I need the air-free condition also for the reactions. So basically for any reactions, if it is not said to be under air, so you should set up the reactions under argon all time or under nitrogen, which one is available. So now I turn off the vacuum and yeah, I remove the needle, and now the sample is getting ready for the reactions. So here I'm sorry, here this flask containing the white compound is ready for the reactions. So here I'm showing you my flask. So before starting reactions, you should invert the rubber septa so that it cannot pass any air or anything, because it is already under vacuum. So before starting reaction, I will put some gas so that the vacuum will be filled with the gas, and I will add all the reagent through this rubber septa. Here in this reaction I don't need to add any solid, so I don't need to open this rubber septa. So I will add the liquid THF and TBAF also in the solution, like liquid form. So that's why I will put a parafilm around this rubber septa so that no air can pass, or like any moisture or anything cannot pass. So here I'm taking the parafilm. So you can take out the parafilm like this, and then you can just wrap it through the rubber septa and the flask to make it more airtight and moisture free situation. So this is now ready for the reactions. So I'm going to use this flask and I will put in the cooling bath. So I made the cooling bath with dry ice and acetone, and I need like -5 degrees Celsius temperature, so you don't need to add too much of the dry ice in the cooling bath. So here I turn on the gas, and this is my gas line, so with the needle. So I will insert this needle directly through the rubber septa, and since the gas was on and it was under vacuum, so it will be okay for now. So now I'm placing the cooling bath where I added some acetone and couple of beads of dry ice. So you should know how much dry ice you can use. So there must be a low temperature thermometer, so I'm going to use very soon. But one thing you can also remember, you can also reduce the temperature like -5 by using ice and sodium chloride salt and ice and any other salt. So whatever is available to your facilities. So since we have the dry ice available, so I can add a small amount controlled weight dry ice in acetone, and then now I'm checking the temperature whether it is -5 degrees Celsius or not. So if it is above -5 degrees Celsius, then I need to use a little bit more dry ice. If it is too low than the -5, then I will use a little bit acetone to adjust the temperature. So here that is actually I was doing. So now I think the temperature is -5 and everything is ready. So first thing first, you can, since my compound is solid here, so before cooling down, you can also use like solvent first, so it will give you the more soluble solution, and then you can start cooling down. So here I didn't start cooling yet, but I put the thermometer. Actually what I said before, that is not correct. So I put the thermometer, and I also now I will add the solution solvent first, like THF, tetrahydrofuran. And what is in, once it is in the solution, then I'm going to use acetone and the dry ice to make it, to cool it down to -5 degrees Celsius. So here you're seeing that I am wearing the gloves. Now I'll bring the tetrahydrofuran solvent, anhydrous. Definitely it should be anhydrous or dry THF. If you don't use anhydrous or dry THF, then the reaction may not occur nicely, and you will get very low yield from the reactions, because THF is like very hygroscopic solvent. So if you keep this THF open or like somewhere, then it can absorb water and it can destroy the solvent quality. So here I have taken the THF solvent bottle, which has a which is covered with the like parafilm, wrapped with the parafilm. So I'm taking out the parafilm. Immediately I will take out the solvent, and it is a sealed bottle. So this bottle is from the Sigma Aldrich. So you can see the rubber septa on top of the bottle. So you can insert your needle through this rubber septa to take out your THF. So first you can add some gas. So this is my gas line. So since I didn't started the reaction yet, so I can use the same gas line, or if you have different gas line, you can use the different gas line. So under gas, take the THF, the amount for this reaction, like I have like 700 milligram scale reaction, so I will need around 9 milliliter of the THF. So I'm taking the 9 milliliter of the THF. Once it is if it is not coming, then you can push back your air again, like gas part or empty part, and then you can fill out up to 9. And once it is 9, then you can take it out and put your gas line back in your reaction system. And you can also bend your needle like this little bit, and then take little gas on top. So on top of the syringe, you can see that there is some gas is taking. So this part will be filled with the gas, and immediately I will insert in through the rubber septa in my reaction system. And I am not adding yet, because to add I have to add my gas line. So here I am adding my gas line. So now I'm taking care of my THF bottle. Immediately put the parafilm on the rubber septa and put the cap, and now add your solvent here. So once the solvent is added, then make sure that you are adding the solvent all over the flask and round wise, so that whatever is stuck in the wall of the glass, it can be dissolved, and it can go to, all of the compound can go to the solution. So now the compound should be in solution, or sometimes it may take a little bit time to go to the solution. In between this time, I'm trying to dissolve the compound, but it is not safe to do. But if you have control in your hand, and if you know what you are doing, then you can do by this way. But sometimes it is better, you can take your flask out and you can do a sonication. So when you have do the rotavap with your compound and it is stuck in the flask with the magnet, and even after adding your solvent, magnet is not moving, so you can just you can do the sonication to dislodge your magnet from the flask. Now here I'm adding the dry ice. in the acetone solution, acetone solvent, and it will reduce the temperature from 20 degrees Celsius to minus 5 degrees Celsius. So once it is minus 5 degrees Celsius, then I will stop adding the dry ice. Okay, so here the temperature is already under minus 5 degrees Celsius. So this reaction is very short time reaction. Decellulation occurs within 2 to 3 minutes at minus 5 degrees Celsius. In some cases, you may also need to do the reaction in room temperature with the TBAF, just at room temperature at the TBAF, and then stir for even some cases it takes like half an hour, 30 minutes, 20 minutes, or 1 hour, depends what is the compound and how they are reactive or not. In some cases you also need to add a little bit acetic acid, a couple of drops of acetic acid in presence of TBAF, so it may give you a good result. So here I have brought the tetrabutyl ammonium fluoride solution that is from the Sigma Aldrich. So that is also a sealed bottle, and there are like some safety things, so don't open it outside the hood, and definitely it has a rubber scepter sealed bottle, so it is safe to dispense the TBAF with the needle, syringe and needle. So it looks like my magnet is not dislodging from the solid yet, so what I will do quickly sonication. I'm trying to dissolve it, but it is not, so maybe it is better to do a quick sonication to dislodge the magnet here. So once it is removed, the stirring bar dislodged from the flask, then I can cool down the solution again to minus 5 degrees Celsius. Now I'm going to the sonicator, so it will take just maybe a couple of seconds to dislodge with the sonication. So sonication by ultrasonic bath. So I think it is done. So I will add the gas line again in my flask. Now I'll put it in the cooling bath. See, the magnet is now moving. Otherwise the reaction, if the magnet is stuck, then reaction will not proceed, because the reaction requires the chemical kinetics, like collision of the molecules, right? So magnet stirring bar always give you that collision for the suitable of the reaction system. So now I added the gas line and also the temperature, and once it is minus 5, making sure it is minus 5 degrees Celsius. If it requires, I may put a little bit more dry ice. If it is not, then don't know. So this TBAF solution, tetrabutyl ammonium fluoride solution, is a flammable solution. It is stored normally in the refrigerator, and it is also corrosive and hazardous for health. So that's why you need to be very precautious to dispense this tetrabutyl ammonium fluoride solution. So it was in the refrigerator. I'm showing you the name. It is from the Sigma Aldrich. So I'm taking out the parafilm again, and now I'll make ready, like you should have a syringe and needle ready before opening the bottle. So make sure that you have dry and new syringe and needle to dispense your tetrabutyl ammonium fluoride solution from the bottle. So here I am making the needle and syringe, new needle and new syringe, to take the tetrabutyl ammonium fluoride solution from the bottle, and I need around 2 point something milliliters. So I'll use the same gas line from my reaction system, or if you have extra gas line, I have extra gas line, but I am using for other purpose sidewise. So this line is available. So Now I'm going to remove the parafilm from the top of this rubber safety seal, and then I will use this gas line. Oh, there is another gas line, so I will use that gas line. I will attach it here. So gas is on, and now I am taking out like around 2 milliliter or a little bit more than the 2 milliliter of TBAF solution from this bottle. So I'm pulling up, and once it is 2.1, around 2.1 milliliter, then I will take it out. So now I'm making ready. So take this solution, and I'm putting a little bit dry ice here to make -5 degrees Celsius again. So here I'm going to add So I'm taking some gas from the bottle also to make the top part of the syringe is empty. So here I am taking out, and immediately I inserted the needle through the rubber septa. Now I will add quickly because this reaction requires 2 minutes. So I will add at a time quickly, no dropwise. So I already added this, and now you have to quench this syringe also, because since it is flammable, so you shouldn't take any risk. So first take care of that TBAF bottle. So put the rubber parafilm on top of this, and then put the cap on the bottle, and once it is done, then put a parafilm around the cap of this bottle. So I'm bringing a parafilm, and now I'm going to attach it. Okay, and once your reaction addition is done, it should go to the refrigerator immediately. You can keep it 5 to 6 minutes, it's fine. 5-10 minutes is okay, as long as you are done with the reaction addition. So now I need to quench this syringe with the sodium bicarbonate solution, saturated sodium bicarbonate solution. So here I'm gonna take some saturated sodium bicarbonate solution in a vial, and then I will take out the syringe with the needle, and then I will pull up the saturated sodium bicarbonate solution, and by this way it will be quenched down in the saturated sodium bicarbonate solution. So while I'm doing this kind of quenching, in between this time, once 2 minutes is done, then I will take out my gas line out, and I will not gas line, actually here I am adding my saturated sodium bicarbonate solution. I take out the cooling bath actually, and now I am adding the saturated sodium bicarbonate solution in the reaction system. So this sodium bicarbonate will quench the excess tetrabutyl ammonium fluoride solution. And after quenching the reaction, I will extract the solution with ethyl acetate, because THF is lighter than water and ethyl acetate is also lighter than water. So both will be on top of the water during the extraction in the separatory funnel. Do not use the DCM. In that case, THF will be on top, DCM will be bottom, water. So it can make an emulsion. So in that case, you can choose which solvent you can use for the extraction. So here, since my reaction solvent was THF, and that's why ethyl acetate will be in the same side, so I will use ethyl acetate for the extraction. So if you like my video, please comment on my video, and give like and click the bell button, and also you can share my video to anyone if anyone want to learn the chemistry and techniques and the lab work. See you then. Bye.